In this video, we'll discuss our first case of partial fraction decomposition, which is when the denominator is a product of distinct linear factors. So no repeating with the linear factors, they're all different. The form of the partial fraction decomposition for a rational expression with distinct linear factors in the denominator is, and I think this is crazy complicated compared to what it is this is whatever you're given. They're just stating in the bottom that it's a bunch of linear factors. Notice how they're all x to the first and all that a sub 1, b sub 1. It's just saying that they're different constants there. So indicating that all these factors are totally different. What we're going to do is we're going to take however many factors you have in the denominator. Each one of these is going to become its own separate fraction. So if you have two denominators, you're going to be adding and subtracting two fractions. If you have three factors in the denominator, you're going to be adding and subtracting three fractions, and so on. That's our setup. Now, our numerator, since our denominator is linear, which is degree 1, we need our numerators to be a lesser degree. Well, what's a lesser degree than degree 1? Degree 0. And degree 0 means that there's no variable there. All it is a constant. So we're going to set this up with a constant in the numerator and each linear factor in its own denominator. Now they're using this notation here. It's out of our book where they're doing A1, A2, A3. I don't know. I don't want to get confused with the A's. So personally, I would opt for A, B, C, D. All right, let's see this in action. We want to find the partial fraction decomposition for 5x minus 1 over x minus 2 times x plus 1. Well, our first step is to set up the partial fraction decomposition with our unknown constants in the numerator. So basically just what we have in the box above us. Since we have two distinct linear factors in the denominator, that means that we're going to have two fractions that we're adding together. And I always put a plus in between. If it's supposed to be minus, then the numerator will end up being negative. So I always just keep it plus. Since our denominators are linear, our numerators have to be a lesser degree. They have to be a constant. So I'm going to use A and B. It's important that you use different variables because we don't necessarily know that those numbers are exactly the same. More than likely, they're going to be different. Once we get it set up, now we want to multiply both sides of our equation by the LCD. And the LCD is always going to be the original denominator. So make sure that you distribute this in to each one of our fractions. When we do this and cancel denominators, we're going to be left with 5x minus 1 equals a times x plus 1 plus b times x minus 2. We want to simplify the right side of our equation by multiplying out and combining like terms. We don't have any like terms to combine, but sometimes we do. We want to write both sides in descending order. Well, the left side already is. So we're going to put ax plus bx first, and then plus a minus 2b second, because remember, x is our variable. Now we want to factor out any x's. And you want to do this kind of in groupings. Now, the way that I'm going to write this is a little different than we typically do. Typically, when we factor out an x, we put it in the front, but this time I'm going to put the x in the back. So this is going to become a plus b times x. And notice our next pairing, they don't have variables, so they're both constants. So I'm going to group those together as well. I think I'm even going to put them in parentheses. All right, that's our fifth step. Our sixth step is to equate coefficients of like powers of x and equate constant terms. So what does that mean? Well, if this equation is equal, and on both sides I have something x and then a constant, that means that the coefficients have to be the same. 5 has to be the same as a plus b because both those things are the coefficient on x, and -1, which is our constant on the left, has to be equal to our constant on the right, a minus 2b. And now we'll set up a system of equations. We have a plus b has to be equal to 5, and then a minus 2b has to be equal to -1. Now we want to solve the system. And use whatever technique you like. I would not opt for matrices or anything here. I think I'm going to use the substitution technique. I'm going to solve this first equation for a. A is equal to 5 minus b. So then we take this 5 minus b and plug it into our other equation for a. It's going to give us 5 minus b minus 2b equals -1. 5 minus 3b equals -1. -3b equals -6. Dividing both sides by -3. We get b equal to 2. We need to go back and solve for a. A is equal to 5 minus b. So a is equal to 5 minus 2. A is equal to 3. Now that we've solved our system, the last thing we need to do is substitute these values that we got for a and b back into our very original statement. So I'm going to take the 3 and plug it in up here for a, and then take 2 and plug it in up here for b. So we're not done yet until we actually write out that statement. We get that 5x minus 1 over x minus 2 times x plus 1 is going to be equal to 3 over x minus 2 plus 2 over x plus 1. In our next video, we'll look at what happens when we have a repeating linear factor in the denominator.